Thank you for the introduction. Ideally, it was not going to be me talking today, so I'm here as a replacement for Tuana. I don't want to steal her thunders. These are her slides, so she's still here with us. Yes, she is. So the idea for today is to think about what kind of challenges we face when doing what we traditionally call knowledge work, and how can we use AI to solve those challenges. And to do that, I'm going to take this example probably to its extreme and think about an invoice. We all use invoices in our daily lives. Most often when we buy a coffee from our local coffee shop, and we might proceed to throw it away. But for a lot of business applications, keeping track of invoices is quite important. And one use case that we see often is the problem of invoice reconciliation. That is, I have a contract that says this company is going to provide these services over, let's say, a year, and every month they're going to send me an invoice. Now, most of the time, there's humans involved in creating invoices, so an invoice might not exactly be what I expect in my contract, and I want to be able to check those invoices to make sure that they are what we agreed upon. This is one example that we see a lot in the industry, when we have these lots of providers, a lot of contracts, a lot of invoices, and we want to make sure that all these invoices make sense. So how do we approach a problem like this with AI? And so it's not trivial that I can just throw the contract, throw the invoice, and say, is this correct? Like we would love that to be the case, but there are some nuances that make this process a little bit harder. So let me run through an example on how this may work. Here we have, I have uploaded a couple of contracts, I have uploaded a couple of invoices, and so one of those contracts might specify the price or the delivery date for particular items, but they don't match the invoice, and I want to very quickly be able to highlight what's going on. So that's sort of what it looks to do invoice reconciliation. And if you're interested in looking at a demo more closely, we are having a demo later today. So do come to the demo. So what makes this problem slightly harder than what it seems? Why can't I just show or throw my contract, my invoice to ChatGPT and ask, like, is this fine? And it turns out that most LLMs or text-based, we are now getting multimodal LLMs, but contracts are PDFs are very complex structures made for human understanding, where layouts, images, plots, or are very easy for a human to understand, but not as easy for an LLM. And so there's a lot of work that needs to be done to extract all this information from these documents before they can fed to an LLM, and that's a crucial part of getting these applications right. Making sure that whatever you're feeding your large language model, it's exactly what they need to solve this problem. And that's where LlamaIndex comes in. So how might we solve this problem? And this is like a very rough approximation. I'm going to show a more complete example in a second. The idea is that we might first upload a contract, and then that contract is parsed. And so if I do this every day, so I'm very familiar with this, but the idea is that we have a PDF and we're going to extract text from that, and we often end up with a markdown representation, which is basically plain text of that contract. That's what I mean by parsing. For this particular application, I might need to find specific clauses on that contract, and contracts might be very large, so I need to do lookup of different parts of the text. This can be achieved, for example, using RAG. And so for these particular applications, once we parse this contract, once we have this text representation of the contract, we are going to throw it into an index into a vector database. We have LlamaIndex in Llama Cloud for this. And we have the first step of this process ready, which is processing the contract. And again, contracts that look like this might have an address somewhere on the top. It might have a table. Again, these are just complex structures that are easy for humans, but not necessarily so much for LLMs. And this is how a contract that's parsed might look like. You can see the table there at the end. Does this have, oh, nice. Then again, here. Once we have the contract, then the next step is the invoice. What do I need? What might I do with the invoice? First step is always parsing again. We need to get all this information as text so that we can do more interesting things with it. But for an invoice, we actually need a lot more details. We need to know, for example, the name of the company. And we need to find the name of the company that invoice. We might need to get all the line items and exactly what was the amount for each line item. So for this, we have a product called Parse that I'm going to mention in a second that allows us to basically solve this step at once. So what is LlamaIndex and what do we do? We provide at the very core level these building blocks that are necessary for doing knowledge work with AI, parse, extract, classification of documents. All these are essential tools that you will need eventually if you're building applications that involve documents. You might know us better for our open source framework that builds upon these tools to build complex AI applications and AI agents. And we are starting to release agent templates that allow you to very quickly prototype complex agentic applications that use documents as their main input and transform them into whatever you need to build. For example, invoice reconciliation. So the idea is that the example that I show, you should be able to get started with one of the templates and in a very few minutes get up and running with a properly agentic application that ingests real documents. So about the core building blocks, I think that Llama Parse is really something special. It's the building block that allows you to go from PDF to text. And there is a lot of optimization behind the scenes to make sure that we understand layouts, that we understand images, that we understand tables, that we understand charts. And so regardless of how complex your document is, there's a good chance that you're going to get much better results by parsing it first and then using an LM. Now, if what you need is structure output, for example, for an invoice, I need line items like what was charged, how much was it, when was it, then I usually want a JSON output for my task. And here is where extracts shines. Extracts allow you to specify a schema. These are the things that I want to get. And ingests your document, parses it behind the scenes, and then gives you the structure output that is essentially what you want. And so here you can see we have a filling from NVIDIA. I might only care about certain specific fields, and so I can just specify that as a schema, and I get that those values only. And it's very easy to get started. You can build your own schemas, but we have a few that are pre-filled for you to use. We also have a mode that automatically suggests a schema for you. So again, it's very easy to get started. If you're a developer, you can also go the programming route, and you can do this by specifying a Pydantic schema. Here, the key is that these descriptions field here are what the LLM will use behind the scenes to understand what's going on. And so they're really, really important. And so if you skim on this, results might not be as good. But again, it's just a couple of lines to get started. also if you go the code route. We are going to share the slides after the talk, but there is a couple of QR codes here. This one takes you to a tutorial on how to use extract for these feelings. Now, if you want to build AI applications, agentic applications, at some point you might need to start putting all these building blocks together. And so, in the ideal world, we just write agents or function agents where we specify a list of tools, and the agent automatically knows what tool to call in what order to get the right output, and that works great. In practice, we sometimes have specific logic that we want to make sure is executed in the right order, and some of those decisions will be agentic. We might have agents that solve particular tasks, but we want a specific flow of our application. And here is where agent workflows shine. One of our core open source contributions is the idea of agent workflows that allow you to build any application specifying different steps and how those steps connect. The idea is that this is event-driven, is built for agents. Most of our agent abstractions are built on top of this. And this is a great way to build agentic applications. This is what the simplest workflow might look like. We can define steps. These steps just print and do nothing. And then steps communicate by specifying events. So first step emits an event. Step 2 expects that event. And so when it sees it firing from this, we'll execute. And this way you can build a very distributed application by specifying when these things should run. This is really useful when you're processing documents where a task might take a minute, for example, and this other task needs to fire only when this is done. This manages all that for you without being blocking. And so we also have tools to visualize some of the workflows. And so if you run this workflow, you might get a visualization, such as this one. Back to our invoice reconciler. If I were to implement this as a workflow, this is what this workflow might look like. I have a step that uploads a file. I might have a classification step that we have a classification module that decides if this is an invoice or a contract. If it's an invoice, I might emit an invoice event. And I'm going to sort of start the workflow that deals with invoices. So I'm going to parse the invoice. I'm going to extract it. I'm going to go back to the contract and I'm going to reconcile it. If I have a contract, I'm going to get the name from the contract. I'm going to index that contract. I'm going to say that contract was indexed. And when I'm reconciling an invoice here, basically what I have is the extracted invoice. I have the extracted contract, and I'm going to use a structure output LLM. This is not necessarily an agent, and say this is what my output should look like. From the parse invoice and from the parse contract, try to find if there are any discrepancies. And this step could be as complex as you want it to be. We are also building tools to make it as easy as possible to deploy agents. So if you build an agentic application with a workflow, we want to make sure that you can deploy it very fast. And so in this case, we developed a tool called LlamaCTL that is the one that has all these agentic templates. So if you type LlamaCTL init, this will very quickly allow you to generate one of these templates, and then you can deploy it, you can run it locally, but you also get all the code. So if you actually want to make any changes to the application, you want to change the schema, you want to change the UI, everything is there for you to customize. We are gonna be doing a demo of exactly this and how this works and how you can get started deploying an agent on the demo later. So I think it's 5:30. Demo booth is over there. Finally, we wrote a paper on how to use LlamaIndex with weight and biases. You can find the link to that blog here if you're interested. And I say we was Tuana, but again, I'm still in her talk, so I get to do this. Again, if you're interested in when to use parse, when to use extract, what is OCR and why we might need parse and not just OCRing a document, these are two interesting blog posts that will be linked with the talk. If you're interested in getting started with agents, this is your main QR code that will take you to the demo on how to properly build these applications. And this is it. We are, as I mentioned, we have our demo and we have swag. So if you're interested in one of these very cute hats or have any questions about LlamaAgents, happy to approach me or Murtaza there. Just search for the hats and we're happy to exchange one of these hats for your time. All right. Thank you.